Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to wrap up Chapter 3, and we're going to talk about a really cool postulate called the HL postulate. And the HL postulate stands for hypotenuse-leg. And what it states, gentlemen, is that if the hypotenuse and a leg of one right triangle are congruent to the corresponding hypotenuse and leg of another triangle, then the two right triangles are congruent. So please be careful. I know I've said this a lot and I'm kind of a broken record, but you cannot assume right angles. You cannot assume right triangles. So if you know that you have two right triangles and you have the hypotenuse and one leg of one triangle congruent to the corresponding hypotenuse and leg of another right triangle, then those two right triangles will be congruent. Okay? So far we've learned about side, 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 angle, side, angle, side, angle, 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 side, and now this one is HL, hypotenuse leg. This is the only one, though, that must have a right triangle involved. In the other triangle congruence theorems and postulates, they do not have to necessarily be right triangles. But for HL, they have to be right triangles. And you have to be able to prove that they are right triangles, okay? I hate to bore you with repeating stuff, but I want to make sure that you guys really understand. So for example, let's take a look at it. If I tell you that triangle ABC is congruent to triangle DEF, or I'm sorry, I don't say if, I say triangle ABC is congruent to triangle DEF if, for example, let's say AC is congruent to DF and BC is congruent to EF. Okay? That would be the case here. Why? Because AC is not only a hypotenuse, but its corresponding hypotenuse on the other triangle is DF. Those are congruent. And if you see from the letters, not the figure, BC corresponds to EF. So if BC is congruent to EF, then I have my HL postulate here, clear. I have corresponding hypotenuses that are congruent, and I have one corresponding leg that is congruent. I could have also stated, though, instead of BC being congruent to EF, I could have told you that AB is congruent to DE, along with the hypotenuse. That would have also worked. All you need is the corresponding hypotenuses and one corresponding legs that are congruent. That's all you need. You don't need both of them, because then if you had everything corresponding and congruent, then that'd be side, side, side. So you just need one leg that is corresponding and congruent, and the hypotenuse. Yes?
Wait, here, how did you figured out that the legs for all of them were...
Well, I told you, I'm telling you that triangle ABC is congruent to triangle DEF if AC is congruent to DF. That has to be. And either BC is congruent to EF or AB is congruent to DE. You need one corresponding leg and the corresponding hypotenuse to be congruent. No, you don't need an angle to be congruent for HL. Now, you do need to know that they are right triangles, yes, but the angle is not part of the congruency. If the angle was part of the congruency here, then it'd be side, angle, side, or angle, angle, side, but that's not what we're proving here. What we're proving here is that hypotenuse leg postulate. you must have two right triangles, and in those two right triangles, one pair of corresponding sides must be congruent, and the hypotenuses, which are corresponding, must be congruent. Thank you very much, sir. All right? So let's get right to it, because that's it. That's the only thing you have. Yes, sir.
But I'm a little confused when you say that if those are congruent, then you need those right there, like the B6 congruent to EF. But wouldn't that just be like the ASS postulate, which doesn't exist?
Okay, no. We are not dealing with the angle here, guys. Again, I don't know why you guys are getting confused with the angle, but apparently I did not do a good job here, so I'm going to do it again. All right? In order for HL to be activated, to be used, you must know that they're both right triangles, okay? And this lets you know that these are both right triangles. That's the only thing that you need. You need two right triangles. You with me so far? Okay, let me get rid of this because the angles are not part of the congruency. They just allow you to activate HL. If I tell you, okay, triangle ABC is congruent to triangle DEF, then that means one of the following. For sure, guaranteed, AC has to be congruent to DF. Why? Because that's a hypotenuse. Okay? And then for this to be congruent because of HL, then either BC has to be congruent to EF, okay? If that's what they give you, you know that these are going to be congruent because of HL. One corresponding leg is congruent, and the hypotenuses, which are corresponding, are congruent. You with me? Or, I'm going to erase this because apparently that caused some confusion. I apologize if it did. Or, you could say that DE is congruent to AB. Okay? Because again, that's one corresponding congruent leg and a hypotenuse. Am I involving the angle in this congruency at all? No. No. This is not side angle side. This is not angle side side. That doesn't exist, and you're right, it doesn't. This is not side side side. This is simply hypotenuse leg. But in order to have a hypotenuse, I must have a right triangle. But the angle is not involved in this postulate. Does that clear it up, sir? For everybody, my brothers? Thank you very much for your honesty. Takes guts to ask. Thank you. All right, guys. So that's the postulate. Let's see how it works. Okay? We have given here that BC is perpendicular to AC. We have that BD is perpendicular to AD. And we have that AC is congruent to AD. I really do enjoy the way we've been doing the proofs with the figure right there to the side of the proof. I believe that it helps us out, so I hope that is true. So let's get to it. First things first, BC is perpendicular to AC. So that means BC is perpendicular to AC, so that means I have a right angle right there. Correct? Okay, that's a given, and we get from there that angle ACB, which I just marked in red, is a right angle. Why? Definition of, actually, that's wrong. I shouldn't have put right angles. It's really definition of perpendicular lines. So I apologize about that. That's my bad. Okay. Does that make sense? Okay, so that's definition of perpendicular lines, not right angles. I apologize. Okay, next, we have another given with another perpendicular, and it states that BD is perpendicular to AD. That's a given. What can we determine from that or infer from that? There you go, my brother. Angle BDA or ADB, however you want to mention it, is a right angle. And so we're going to go ahead and label it. You know, I love to label things. Okay. Why? Again, Not definition of right angles. That is my bad. Again, I apologize. It is perpendicular. Definition of perpendicular lines. Again, I apologize. That's my bad. Okay? Now, we know that there are two right triangles, correct? Guys, you with me here? So now, what I'm going to do, AC is congruent to AD. That is a given. Okay? So I'm going to go ahead and mark it. AC is congruent to AD. And then, go ahead, my man. No, no. You do not have to prove that ACB is congruent to ADB here. Because I don't need that. When I have a right triangle, you want to always try to see if you can prove it through HL. And you do not need to prove that the right angles are congruent. If you put that in the proof, is it wrong? No. But is it useful? Not really. Okay? But what is useful is that AB is congruent to AB because of the reflexive property. You guys with me here? Now I can prove that triangle ACB, I'll highlight it in green, is congruent to triangle ADB, which I'll highlight in blue, because of HL, hypotenuse-leg. You have a shared hypotenuse, which is congruent to itself, AB, and you have a corresponding congruent leg, AC and AD. That's HL. You do not need to prove that the right angles are congruent. And anyways, it wouldn't help you here because then you'd have ASS. And ASS is not one of the congruency postulates, gentlemen. Now from here, I want to prove that AB bisects angle CAD. Well, using CPCTC, I can prove that angle CAB is congruent to angle DAB because of CPCTC. And if those two angles are congruent, well then AB bisects angle CAD, definition of angle bisector. Does that make sense? Bless you. Does that make sense, gentlemen? You promise? Okay. Yes, sir.
Wait, so first,
No, I didn't prove anything about the angles, sir. I proved that the triangle, which I highlighted in green, triangle ACB, is congruent to the triangle highlighted in blue, which is triangle ADB, are congruent because of HL.
yeah.
Then I proved that angle CAB is congruent to DAB because of CPCTC.
Yeah, no, I was talking about part 8.
Yeah, number 8.
Prove that there were two.
Yes, I proved there were two congruent angles because of CPCTC. Yes, absolutely. Corresponding parts of congruent triangles are congruent. What's your question? And then I proved that AB bisects CAD because of definition of angle bisector. My brother, thank you for your honesty. Look, if this AB bisects this whole angle, doesn't it cut these two into perfect halves? Which I proved in step number 8. That make sense, my man? Thank you, sir. Yes, sir.
I understand what you did with HL,
Correct?
but I don't know, I don't understand why you couldn't have the right triangles congruent to side angle sides.
Okay. You don't have side angle side, son. You don't have side angle side, son. This, if you wanted to prove that C was congruent to D, you'd have angle side side. That is not side angle side. In order for you to do side angle side, you would have need to know that CB is congruent to BD. And you cannot prove that. Are you with me, son?
I don't see how the side angle see side angle.
How do you, no, you see side angle side because I proved this after I proved the congruency. Let's go back. That's HL, son. Now that they're congruent, now I can say angle CAB is congruent to angle DAB because of CPCTC. But you can't go forward and they say, oh yeah, now let's do side angle side. You had to prove that they were congruent first because of HL. Then you could prove that this angle is congruent to that angle. Are you with me, my man? You sure? These are great questions and I appreciate it. You promise. Anyone else? Don't make a mountain out of a molehill here, guys. All right, let's continue then, please. And thank you. Okay. They tell you right off the bat that KPR is congruent to triangle, bless you, SAW. They tell you that RM bisects angle KRP and that WT bisects angle SWA. They want to prove that RM is congruent to WT. So you want to prove here in the end that RM, this guy right here, is congruent to WT. Okay? So again, let's go down so we could see everything that's happening here in detail. And the first thing they tell you is that triangle KPR is congruent to triangle SAW. Okay, so I'm going to highlight that in purple. Okay, both of them. So I've got KPR, the whole triangle, is congruent to triangle SAW, the whole triangle. Okay, you with me here? Yes, no, maybe, kind of, sort of? Okay. Now, they also tell you that KR is congruent to SW. So that's CPCTC. KR, which is this guy, is congruent to SW, CPCTC. Then from here I could, yes sir? I'm sorry, my man? Okay, just because it's congruent doesn't mean that you can just put tick marks. You have to prove why. I put the tick marks of SW to KR because I have to say that corresponding parts of congruent triangles are congruent. We know that everything is congruent, you're right, but I have to articulate it. Okay? Now from here, I can very easily say now also that angle K is congruent to angle S also because of CPCTC. Okay? Then I can also state that angle KRP is congruent to SWA also because of CPCTC. So KRP is congruent to angle SWA because of CPCTC. Remember what we're trying to prove here though, guys. We're trying to prove that this here is congruent to this. Okay? I tell you now there's another given that says RM is bisects angle KRP and WT bisects SWA. Those are both given. And if RM bisects KRP and WT bisects SWA, and we already know that angle KRP and angle SWA are congruent, what do we know about halves of congruent angles? They are congruent. So I have a double bisector here. So I could say now that angle KRM, which is this piece here, is congruent to angle SWT, which is this piece right there, because of division property. Halves of congruent angles are congruent. Now I can state that triangle, I'll do it in blue, STW is congruent to triangle KMR because of angle, side, angle. And then from there, I can easily prove that RM is congruent to WT because of CPCTC. Now, some of you may say, what about HL? Were we ever given any information about a right angle or a right triangle here? So HL is off the books here. It's not even a remote possibility. Are you guys following this proof? Do you understand what we did here? Label, 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 label. Draw those triangles out. Tick marks. It helps. Yes, sir. It could not be multiplication because I'm going from large to small. Large to small would be division, sir. Thank you, sir. Yes, sir. No, if not only would it be unnecessary, it would be wrong. I'm going from large to small, so that's not multiplying. Thank you, sir. Yes, sir. Nope. If there's no right triangle, if there are no right triangles, it is impossible to be HL. Like it's not even a remote possibility. So that could just leave your bank, your knowledge bank. If you don't see right triangles or any proof of perpendicularity, or you don't see an altitude, remember an altitude forms 90s, you don't see that, you cannot use HL. Now, thank you. Great question. All right. May I continue, my brothers? Okay. Last but definitely not least, I have here a circle O, and I say that OF is an altitude. All right. Now remember what we had just finished talking about. If you are mentioning perpendicular lines, if they mention altitudes, then we're talking about 90s, okay? Then we're talking about right angles. So right off the bat here, OF is an altitude. Okay, so what does that tell you? What does that tell you? If OF is an altitude, what can you immediately ascertain? Yes, sir. I'm sorry, my brother? Yes, and you said it correctly before, and very, very awesome, my brother. EFO or OFE and angle GFO or angle OFG are right angles. Absolutely. That's a right angle, and that's a right angle. Why? Definition of altitude. Absolutely, my brother. Great. Now, what do we know about OF here, guys? Take a look at what you have here. Absolutely, OF is congruent to OF because of reflexive property. Not only could I, but I would. Fantastic. I'm very proud of you. Let's see here. Let me erase that little mark here. Yes, sir? GF, you could say OFG or GFO. That's what I have there.
Don't you have to say that
Why would you have to say they're congruent? Think about it. Whenever we're dealing with right triangles now, we have the possibility of doing HL. Now look, if you did say that they were congruent, do you have any way of proving that EF, I'll just mark it, that EF is congruent to FG? Is there any way for you to prove that? So what would the use of proving that angle OFE is congruent to OFG be? You cannot prove that because of side angle side, because there's no way to prove that EF is congruent to FG. Are you guys understanding this? This is a common mistake. I'm proud of you guys. You guys are thinking the right way. But you got to think a little bit ahead of the game in this one. You cannot prove that EF is congruent to FG, so side angle side would not be a possibility. So you would just be wasting a little bit of time if you mention that angle OFE is congruent to OFG. Now, if you put that in the proof, are you saying a wrong statement? No. But it's just not going to give you anything. It's not going to lead you anywhere. So let me get rid of that because They're not. Now, I can say that yes, sir. Okay. I can say that circle O is there because that's given. And now that I know that circle O is there, what can I say? Yes, sir. Absolutely. OG is congruent to OE because all radii are congruent. Okay? All radii are congruent. Now, look at what I have here, guys. Do I have two corresponding hypotenuses that are congruent? Do I have a corresponding pair of sides that are congruent? So now I can prove that triangle OEF is congruent to triangle OGF because of HL. And now I can prove, now and only now, can I prove that EF is congruent to FG because of CPCTC. Do you guys clearly see how side angle side would have been an impossible way to prove these triangles are congruent? Because that's the main theme here. Once you have the knowledge of HL, you don't need to worry about the angle congruency here. Yes, sir.
I get everything. I just don't get
Okay. How could I use side angle side? Let me go back again. I appreciate it greatly. Okay. I have proven up to here, son. How can you prove side angle side here? Correct. You don't have side angle side. You have angle side side. And that does not exist. There is no way to prove that EF is congruent to FG until you prove by HL that triangle OEF is congruent to triangle OGF. I really appreciate the honesty. Does that make sense, everybody? You promise? All right. Thank you very much, guys. I hope you learned a lot, and have a wonderful day.